First, let me share my screen and show you some. All right. Okay. So, so in today's session, we are going to have an overview, okay? Uh, Overview of Google Cloud. Okay? So it's going to be an overview of Google Cloud, okay? And then budgets and alerts in Google Cloud. Okay? So that is the most important thing whenever you go in for using any cloud. Okay, so you need to set up budgets and alerts. Okay, and then finally, we are going to explore BigQuery. Okay, what is okay, and then we are going to do sample data loading. Okay, and then maybe finally learning journey. Okay, so you can self-learn BigQuery. Okay, but if you still want, you can always buy my book, Learning Google BigQuery, and go with it. Okay. Okay. So first, okay, and foremost, let's go to Google. Okay. So if you ever wanted to sign up Google using your own personal account, you can go to cloud.google.com. Okay. And they actually give three I think $200 of trial or something. Okay. And we have already exhausted it, but maybe I will show you in an incognito window. Okay, that they give a trial amount, which is very good to start with, and I think its duration keeps getting changed. Okay, but let me see. Okay, so maybe I think I might have already used it. Let me try. Um, right. But I'm not going to sign up for trial, but I'm just going to show you. And I think this ID also, I think I already used it. I'm not wrong. Let's see. Okay. Yeah. Okay. So yeah, I have already used everything. Okay. But if you go there, they will give you trial. Okay. So once you sign up for the trial, okay, using your Google account, okay, you have to set up budgets and alerts. Okay. This is very, very important. Okay. So you have to set up budgets and alerts because in cloud, any mistake that you do, okay, your resources will be exposed to general public. Okay, and it will cause a spike in the uh, monthly amount you pay. Okay, so the recommendation is you put a budget and then an alert so that when you are about to reach the budget or something, whatever conditions you have set up, you receive an email. Okay, and people have been very, very badly hurt because they haven't set up these budgets and alerts. Okay, so once I think somebody checked in some kind of a code with some libraries, like some secret keys into public GitHub, and miners started using it for mining crypto coins. Okay, and they got a hefty bill. Okay, and again, it's very difficult to prove to cloud providers that it was a genuine hacking as well. Okay, so just to be cautious, always set up the budgets and alerts so that way it is. Okay? So the budget and alerts, how do we set up? It's very simple. Create a budget, okay, and then there are various levels in which we can do it. Okay, let's say I'm going to say production environment. You have to have overall budget. Okay, so maybe I'll start with that. I have a overall budget. Okay, all clients budget. Okay, so if you want to create, so let's say overall budget. Okay, that means across all projects that I allocate for different clients. I want a budget, monthly budget, okay? And again, make sure it's all the projects are selected, okay? Or if you want specific, you have to go, but set up everything for all projects, all services. Very important, all projects, all services, okay? And include discounts and promotions, okay? So that way that gets deducted. And then next, okay? Let's say my monthly target is 7,000 rupees. That's what I want to spend for my projects. Okay. So, and then you can set up alerts at various levels. So by default, Google says you will get an alert when the monthly budget reaches 50%, that is 3,500. Okay, and if it reaches 90%, you'll get an alert. Okay, if you want to add your own threshold, go ahead and add it. Okay, so let's say you want to add 75%, go ahead and add it. Okay, and then once you have it, email alert to billing admins and users, and then you can just finish it. Okay, so this is your overall budget. Okay, and then you can set up budgets as per the environments. Okay, so I'll explain that. Okay, but you can always select few projects. Okay, let's say production project budgets. Okay, obviously you want to spend more for production, and for testing, you want to spend only half of it or less than half of it for production, right? So production projects, you choose whatever production projects you want. Okay, so these are all production projects, let's assume. Okay, all services, and then you set up some budget for it. Okay, so let's say for this I'm going to spend only 3,000. Okay, so and then obviously it will show all things, and then you can do it. So always make sure you set up budgets and alerts before you proceed. Okay, and one budget should be there for all the clients or overall budget. Okay, and that is at an account level. So that is how we use it. Okay, so when you sign up for Google Cloud or even AWS or Azure, always look for budgets and alerts before you use any service. Yeah. If you are not able to set up budgets or alerts, and if there is any error, don't do anything to cloud. That is my advice. Okay. So we covered the first one. Okay. And in Google Cloud, okay, the next part is, okay, what we call it as a concept is called project. Okay, so there is something called project. Okay, and since we use Jusuit, okay, we will give Nobilance, okay, .com, and then here for each client or each project that you get, okay, you have to create a new project. Okay, so let's say you are developing a e-commerce project, right? So for e-commerce project, you will have a dev site to host and test, and then test site, and then a prod side, right? So let's say, okay, you wanted to keep all these separate so that nobody can, people who access dev can't access test, and people who access test can't access prod. If you want to do it, then you have to create 3 different projects. Okay, that is why it is always better you organize it by folders. Okay, so if you click here, you can, I think, all projects, I believe, you can go. Yeah, so it will take you to all the projects. Okay, and then here you can definitely, here. So in our case, we can create a test project. Okay? So you have to create a test project, and again, this test project should not be allowed to be created by anyone and everyone. This has to be done by the organization admin. Otherwise, they can't control the building. Okay, so this has to be done only by admin. In this case, in our company, you have to come to me so that I will create the project that you need. Okay. So once you create project, one day after that, you can add service. Okay. So let's say I'm going to create a project, BigQuery, okay, Meetup demo. So this is the project. Okay. And let me put the date 2022, 10, 13. Okay. And then you can look, this project ID is there. Okay, this cannot be changed later, so you have to be very careful. Okay, and this is always lowercase and somehow gets it from here. Okay, and once you create it, this cannot be changed, but this can be changed. Okay. So you have to understand, and this is needed whenever we write any code or Python or all. uh, okay, so we are now creating a project in Google Cloud. Okay, and this is the name of the project, and this is the ID. I'm creating it under my organization in Gsuite, novelance.com. If you don't use Gsuite and use your personal account, okay, you won't see organization. Okay, and it will still allow you to create project. So I'm creating this project now. Okay, so this will take few seconds. Let's see. Okay, so now, again, once this project is selected, click on select project. Okay, and you are here. Okay, by default, to some extent, some services will be allowed to run. Okay, but if you want to have full settings, okay, you have to go, okay, and get a billing. You have to set up the billing for this project. Okay. So if you set up billing, okay, so that way, billing account, you have to map a billing account, okay, and then it will allow you to go over the quota, all those things. And if you don't have that, obviously you won't be allowed to go over the quota. Okay? So it has to have billing, okay. And the worst case scenario, right? If somebody hacks my project, right? Somebody has hacked my project and they're using all the resources, and I don't know how to shut down or find out which service is being hacked, all those things. All you need to do is, okay, come to the project's homepage and then go to project settings. And here you will see shutdown. Click on shutdown. That's it. You protect your billing. Okay. So this is very, very important. Okay. So you shut it down, that project, and then, nobody can do it. And later you can go back and even disable billing. Okay. So you can go back and disable billing, but you can shut it down. In case if you don't know, if you can't find the home option, always you can click on the select this project here from the top, and then go here. There is something called IAM admin. That's where you add users and others. Okay. So once you click on this, okay, then you will come here, and then here you will have settings. Okay. And once you click the settings, you will see shutdown. Okay. So you have to make sure, okay, if something goes wrong, if somebody is exploiting and the billing is going very high, okay, shut it down, go to the billing reports, analyze what happened, and then you will use it. Okay. So that's how we do it. Okay. So for billing, okay, I will again give a separate walkthrough for billing before we go anywhere. Okay. So there is option for billing. I'm going to show what our billing is, real billing is, right? For one of the accounts we are using. Okay, so you can go to reports, okay, and you can do it at a month level. Okay, not a problem at all. Okay. So and again, we are now diversified. Okay, so we are not that much into this. Okay, so let's say current month. Okay, billing. Okay, and then if you want, you can put a bar chart, so it will show at a daily level how much we are incurring. Okay, so Saturday is the last day where I took all the backup of serotonin and then I shut it down. Okay, after that, serotonin traffic will be very, very less. It's only storage for that. Okay, so nothing much. I shut it down the MySQL instance. Um, and then I think this will allow you to choose different months. Yeah, so here, okay, it will allow you to choose months. Okay, from let's say you want to see year over year, right? So let's say September 2020, okay, to September 2022, okay, and then it will show this, okay, and then you don't want it at daily level, it is very tough. So click on month level, and then it will show month level, okay, how was your billing, okay, and then if you want to see by specific project, right? So let's say I want to see group by project, sorry, you choose project, and then in all projects, I don't want all, okay, so here. One search here. Uh, yeah. So this is a project, most important project for us. So I will just put serotonin, and once you're here, serotonin, so far we have spent 60,000 rupees last 13 months. Okay, for this one, okay? It's a MySQL instance that runs of all the things. Okay, and then if you still want to see at a service level, right, under this project, okay, what was the service that cost? I know it is Cloud SQL, so I want to just check by Cloud SQL. Okay, and then okay, by Cloud SQL, okay, this will be charged. It will break it down and even show you, okay, for just that. Okay, so here group by project. So if you want, you can put service. Okay, and then now it will break it down by service. Okay, so for this project, okay, serotonin DB for one service that you have selected, we have paid this much. Okay, then let's add storage. Okay, sorry, not project. Let's add the storage, Google Cloud Storage service. Okay, so and see how much we are charged for that. So for service charge for last 1 year, we were charged only this much. Okay, so that's how it is. Okay, so and then again, so billing, okay, get a handle of the billing. Okay, but at least worst case scenario, you should know, okay, how to go to any project. Okay, and then go to select the project and shut it down if you face any issues. Okay, so again, go here, and there is a IAM and admin option. Okay, select on it, and then on the left side there will be a settings option. Okay, and there will be option to shut it down, and finally you can shut it down. Okay, things go wrong. So that way, any service that is running off of this project will not. And the next thing is, okay, I will give a primer of various services that we have used. Okay? So obviously we use App Engine. Okay, any website or any API. Okay, we actually host it on API App Engine. Okay, and App Engine comes in two flavors. Okay, standard and okay, and flexible. Okay, so standard is we have a lot of restrictions. Okay, flexible is little more. Okay, and almost all languages are supported here. Okay, so you can write anything: Python, Java, PHP, Node, Go, all those things. Okay, so you don't need to worry. Okay, so App Engine is something we use. Okay, and then cloud storage, definitely anything that the user uploads in your web application should actually go into cloud storage. Okay, and that is something is a standard that we have to follow. Any web application, anything, we don't want a storage at a server level. Okay? Basic architecture when it comes to cloud is separate, okay, computing and storage. Okay? Don't use a server where your PHP code or Python code is running to also store files. Okay, don't do that. That is not how things are supposed to work in cloud. You are supposed to decouple both computing and storage. Okay, and as you know, right, one of the sites that we develop, okay, output.co.uk, anything, any new product details that gets updated, all the images and other things will actually go into uh, the cloud storage buckets. Okay, so that's how we have designed the site as well. Okay? And initially we tried to host it in App Engine, and then later we went on to the server mode. So again, have a little bit of understanding. Okay, and as a project lead, if you are given a set of projects in Google Cloud, it is your responsibility to also monitor billing every day. Okay, so that is very, very important. Okay, so you have to understand and monitor the billing every day. Okay, so that is how it will actually work. Okay. So let's see. Okay, and then finally, okay, let's get into the thing called APIs and services. Okay, so mostly you have to keep an eye on this at a project level. Okay, if you look here, these are the default APIs that are enabled. Okay, so by default, BigQuery API is enabled, BigQuery migration, BigQuery storage, cloud data store, cloud debugger, logging, monitoring, cloud SQL, cloud storage, storage API, all those things. Okay, they all get actually um, um, enabled. Okay, at the start. Okay, so we have to be very careful and keep an eye periodically every month, review all the APIs that have been okay, that have been enabled, so that if there is something unwanted, you have to go and disable it. Okay, let's say you don't want users in this project to use BigQuery at all. Go, and you are the admin, right? So you go ahead and click on disable API. Okay, so you have to understand it. Okay, so disable API, again, keep it tight. Okay, security wise, and even if they are your own employees or your own users, okay, don't enable don't give permissions to users. Okay, so now I'm going to give something some permissions to some people and show you what the test is. Okay, so let's go to cloud IAM. Yeah, I'm going to invite few people. Okay. So by default, I think somebody got invited, Dinesh. Okay. So Dinesh became the owner. Okay. So I am also the owner. Okay. And again, this is where the risk is, right? So by default, he is added. So because I have an organization policy under which I have added Dinesh as a rule to add Dinesh to be the owner for all new projects that I create. Okay. So there are a few things, okay, that needs to be revisited. Okay. So now I'm going to add somebody, okay, as a project viewer. Okay. So let's say, okay, so I'm going to add Tiarani, okay, and select the road. The basics is at a project level. So let's say I'm going to give her editor access, right? As soon as I give and she logs in, okay, and starts using it, Google will track what she is doing And if she's not using any of the services, Google will start complaining, saying, hey, you granted permission to somebody, and they are actually um, there are more access permissions to them than what they need. Okay, Google itself will recommend. Okay, so if you come here, okay, now this will tell you. Okay, this is one of the projects. Okay, and it says, these are the people. Okay, and again, these people got access permissions. Okay, so this is what it's saying. Okay, so you are not supposed to give such permissions. Okay, so we are very careful. Google itself will do it, so you have to have a discipline to audit these things periodically. Okay. So finally, let's come to BigQuery. Okay, so I'll keep the screen open, but I'll go back to the notepad and give you a little bit of a timer. uh okay, so fine. Okay, so as of now, okay, we have all used RDBMS, right? So some of the RDBMS, okay. What are some of the RDBMS you guys have used? Can you list me few of them? And can somebody tell what are the RDBMS that you guys have used?
SQL Server.
Okay, SQL Server. Okay.
Postgres.
Postgres. Okay. Okay. Fine. Okay. What else? Okay. And then since my MySQL, I'm also I have used MariaDB in some. Okay. So these are some of the RDBMS, right? So RDBMS, as you know, okay, R is the very important, right? Relational. Okay. And now, there are a lot of databases coming up, right? NoSQL, right? So Mongo, okay, and DocumentDB, yeah, all those things are coming up. Okay. So similarly, okay, in lines of it, okay, as you know, in RDBMS itself, okay, we are supposed to follow a discipline. Okay, a discipline is transaction tables and reporting tables must be separate. Okay, never use transaction tables for reporting. Okay, transaction tables must be highly normalized for performance. Okay, whereas reporting tables, okay, will have more indexes, okay, and actually they should be denormalized as possible, as much as they can. Okay, so they have to be denormalized. Okay, so that is what. Okay, so we, and then every day, okay, have a ETL job that will take data from transaction tables and move it to reporting tables at least once a day, right? So this is the very basic discipline that people should have when it comes to RDBMS. Okay? Even if you are writing a ASP.NET application and other things, okay, it's supposed to be like this. Okay, if you have any reports, okay, or if you are using SSRS reports, right, of a SQL server, that should always use this. Okay, but the way people circumvent it is they create a views on transaction tables. Okay, while this is a workaround, this is not a solution. Okay, so you have to have enough discipline. Okay, the first call that we get for from clients is not even BigQuery. The first thing they will call us for is they will tell the SSRS reports are very slow in our company. Okay, or the reports are very slow in Power BI. Okay, can you come in and help us? Okay, when I go in and review their structure, obviously this is where they failed in the first place. Okay, they don't have any reporting table. So now we, instead of moving them to BigQuery or anything, we recommend them to come up with new set of reporting tables, new ETL jobs, and have it on premise, run it for a month or even a year, and then you call us so that we will come back and help you to move it to cloud. Okay, if this is not there, the challenge that we as a vendors have is we are not able to give a projection for their cloud billing. Okay, even today when I walk into any company, the biggest objection, and I have to overcome that to the client, is the pricing objection for cloud. Okay, they want to know what is the amount that they will be spending on cloud for this project. right? So you have to have fingertips, okay, how to do it, and that's where pre-sales team comes into picture. So again, this is a very basic discipline. Okay. So in RDBMS, okay, again, you guys know, right? So MySQL has lot of database engines. I don't know if people have seen it. Okay. So MySQL database engines. Okay. So if you go for this, okay, there are 16 alternative engines. It's not just one. Okay. And for each of them, they will explain where you have to, for which use case you have to use. If you want ACID compliant transactions, go with InnoD. Okay. And again, if you want table level locking, do it. Okay. If you want store all of them in memory, do it. Okay. If you want file based database, go ahead and do it. Okay. If you want to store archive data, go ahead and do it. Okay. So lot of engines. Okay. So they give very good things. So if you are a MySQL person, you can go through this and you have to filter out which one you want and then start working on. Okay. So similarly, okay, for SQL server, right? You have to understand. So SQL server, the database engine is for transaction. Okay. But for reporting, right? The moment you open this SQL Studio, it will ask, right, what type of engine you want to connect to. Yeah, let me show that. Okay. So here it shows SQL, sorry, not authentication. Here, database engine, right? So if you want to connect to reports, go ahead and use reports. And if you want to kind of do ETL jobs, go ahead and use integration services. And if you want to use analysis, right? That's when you go and use SSAS. Okay. So you connect to different types of engine in SQL Server also. Okay. So don't use everything for this. Okay. So that way, okay, for database engine and other things. So similarly, okay, now I want to explain what BigQuery is. It is actually a data warehouse. Okay, for big data. Okay, that means you can still use it, but it is not the best use case for insert, update, delete. Okay, this is actually mainly for reporting. BigQuery is used for reporting and not for transaction. Okay. So you can still insert single record, delete single record, or update single records, no problem at all. It's fine, but that is not what BigQuery is built for. And you will have a latency. Okay, I'm going to prove it to you. Okay, when you execute the insert statement, update statement, or delete statement, there will be a more latency compared to this. Okay, but still, okay, BigQuery supports inserts in two modes. Okay, one is streaming, where you insert row by row using SQL or API. Okay. And the other one is batch. Okay. So where you import from file. Okay. And the biggest thing is this costs money and this is free. Okay. So you would by now understand why BigQuery encourages batch insert instead of streaming. Okay. Because for them, transaction wise is individual records transaction is very costly for the system. But if you do it in batch, it's actually very cheap for BigQuery as well. Okay. So this is where we are. So always make sure that's why we write ETL jobs. Okay. That will take 100,000, 1 million rows, 2 million rows and insert it to BigQuery. Got it? Okay. So let's see. And then okay, and then okay, so BigQuery is columnar structure. Okay. Okay, so that means okay, number one, no indexes. Okay, and you guys know, right? Traditional DB has clustered index. Okay, for the primary key. Okay, and then non-clustered index. Okay, mainly we build it for order by, right? Okay, order by and search, right? So for example, primary key is employee ID, but most of the times we are supposed to sort it by employee first name, right? Then you create a non-clustered index. based on first name. And let's say if you're sorting by first name and last name, combine both of them and create one non-clustered index. Okay. That way it is used. Okay. And even searching wise, right? If you are searching by first name, last name, mostly instead of ID, obviously this non-clustered index will help you. Okay. So, but the only problem is BigQuery doesn't have any of these. Okay. They have a columnar structure. Okay. But I don't want to give the exact uh, implementation, but I'll give you a small hint from here and there. So it is, you can imagine almost like storing, okay, distinct values of each column in a bucket and have a mapping for the record. Okay, so there are internal papers. So if you understand it, you will get it. Okay, uh, okay, so you will get it. It stores distinct values. Okay, not like how you store it in spreadsheet. That's not how it is stored. Okay, traditional RDBMS do that. It stores the data in a for each row. Okay, it will have one row with all the values. Okay, but that's not how BigQuery does it. It actually stores distinct values of columns and then gets a pointer for each of the value for that record and stores it. Okay, something like that. Okay, it is columnar based. Okay, so you have to understand it. Okay, so you have to understand. And then the third thing you have to understand is, okay, billing is for the number of columns in select and where order by group by. Okay, so since it is columnar based, billing itself by columns. I'm going to show you, okay, how it works. Okay, so make sure you don't use unnecessary columns. Okay, and have it. Okay, so with that, okay, let's do some practical hands-on and then let's come back. Okay, so BigQuery itself, when you sign up, it will give you public data. Okay, so let's say I'm going to use, obviously I already in Austin, so I will use this example. Okay, so this is, if you go here, it's a public data set where I think people called for something like complaints. Okay, and then it will do it. Okay, so let's take this table, right? I'm going to query it into split table. Okay, and here in BigQuery you can imagine each of them, each what you call as database is called as data set here. Okay, and below that you just have tables. Okay, and you can create stored procedure, views, all those things. So don't worry, as long as you know SQL, learning BigQuery is not at all a big part. Okay, it's only the architecture part that is challenging in BigQuery. But once you are into the data is into the BigQuery, if you know SQL, you can pretty much develop any report. Okay, so this is the data set. Okay, and now let's check this table. Okay, first, okay, so the table is uh, having 1,000 rows. Okay, maybe we will get something bigger. Okay, let's say um, Bitcoin, right? So let's get Bitcoin's tables. I think they would be much bigger. Blocks, partition. Yeah. Okay. So this is partition. Okay, I'll explain what partition is, but for now, okay, there are 7 lakh rows. Okay, and the total bytes is actually 237 MB. Okay, so now I'm going to query, okay, and show you. So I'm going to do something stupid, but just show you. Okay, so here select star from. Okay, let's see what it does. Okay, it is trying to query all the data, 237.67 MB. Okay, and 237. So it is trying to get all the data. That means your query is going to be expensive. So now I'm going to list only the columns that I need. Okay, so let me go back to schema. So I need hash size. Okay, weight. Let's add one by one. Hash. I just need hash. Okay, so now, okay, I think it's a keyword. So I'm going to put it here. What, select that. Okay, maybe I'll try. Whoops. Mm, okay. Okay. So if it is a keyword, okay, please make sure you put it into the tilde operator. Okay. So hash. So now if you look at, I added only one column and it is 47 MB. Okay. And then now I'm going to add the next column, that is size. I hope that is not a keyword. Okay. Who designed it? I think they didn't think you. Okay. Now it is total 53 MB for 2 columns. Okay. Now I'm going to add weight. Okay. So now it is 59 columns. Okay. Now, okay, I think from what I understand, maybe which one could be the most one. Yeah. So my guess is the number of the block. I think when you add number, it may go up dramatically. Okay. Let's see. Number. Okay. So 65. Okay. So it is up. And now I don't want the data. Now, if you look at this table, what they have done is they have actually partitioned it at a day level, okay, using a column called timestamp month. Okay. And if you go to schema, there's a column called timestamp month. Okay. So now I'm going to use that in the where class, where timestamp month is equal to 2022 then 01. So I'm going to get only 1 day's worth of data. You can see it is only 1 KB. Sorry, 192 KB. Okay. And then let's say I want for full month of September. Okay. 0901 and 2022-0930. Okay, so 430. So the more you narrow the data, the more money you save in the query. Okay, and again, in our projects that I have worked on, even though developers are we give freedom for them to write any queries, we always, okay, let's say you run this, right? As a project admin, we always, okay, let it run. Okay, so it runs and then it gets you 4,373 rows. All those is fine. Okay, but what we do is, okay, whenever we have time, we go to the project history, okay, and we look at the query history, and then here, okay, there is bytes build. Okay, there are a few fields, okay, based on which okay, this one job ID status created on. Uh, so, yeah, so here you can see bytes processed and byte build, right? The minimum billing is 10 MB, even though your query used only 160, 190 KB, the minimum billing is 10 MB. Okay, so you have to keep that in mind. Okay, so 10 MB, okay, is what it is, but actual bytes process is only 430 KB. Okay, so that is how we do it. And then again, any query that you execute, okay, it will be cached for 24 hours. Okay, how do we know that, right? So if you look at here, okay, there will be a flag, start time, duration. Okay, so now you don't see that flag, you can see it. Now I'm going to run the same query again and let's see what happens. Okay, so you don't see a flag called query cache here. Okay, so let's run it now. Then let's come back. Okay, I think it won't be here, but if I go to the project history, it will actually show here. So I ran this query at 5.9, I ran this query at 5.10. So if I click on this, okay, it will show, okay, this, oh, this is a public data, it is not doing it, okay. But if you have it in your projects, okay, it will actually get it from the cache. Okay, so any query that you run for your project data, this is the public data. Okay, it will be cached 24 hours for the same user. It is cached at a user account level, not at the project level. Okay, so that's what it is. Okay? So now we saw how to query it. Okay, be careful, use only the columns you need and don't do anything. And now we are going to do a small demo of how to get a sample data into BigQuery. Okay? So we will create a new data set. Okay, finally, maybe I'll put just what purchase order. Okay, Nitya did the purchase order one. And then if you have some complaints, choose the right region. Okay. Let's say you are from US and your data is healthcare data, which has some personal information. Don't store it in Europe or Asia. That is actually a violation as per the regulation. So you kind of get what location we are supposed to store as per. And if you're creating a temp data set, okay, always use this so that any table left out will be deleted after the days. If I put 10, what happens is any table that is older than 10 days will get deleted every day. Okay, so it is only applicable for temp. Don't do it for any other database data sets. Okay, so right now I'm going to create one and uh, let it create. Okay, so it is created already exists. Okay, so means it. I just clicked it twice. Now I'm going to create a new table. Okay, that's where I have a challenge. So first is I want to create the products table. I have it in a spreadsheet and I'm going to download it as a CSV. Okay, and now I'm going to come here, create a table. Okay, you can create a empty table, not a problem. Okay, so if you want, you can always create products. Okay, and then native table. I will explain what native table is. Okay, you can assume BigQuery as a query engine, which can also query your data from Google Cloud Storage, Google Sheet, and now it may even soon be actively available to query Redshift data. Okay, so that's why they are bringing it in. Okay, so I will show a linked data also, and then here for schema, you can type. If you want GUI based, you can always keep typing it. Okay, product ID. Okay, and if you want it to be integer, select integer, nullable, whatever it is, you do it. Okay, and other things. So repeated and other things comes from this is again like a NoSQL, so you can have a record within a record. Okay, one column itself can be a record. Okay, so that is how it is. Okay, so if you want, I will show you a sample after this. Okay, so I will make a note here. ES schema. So I'll show you this. Okay? So you can add the fields, okay? And then if you want to partition, you can always partition, otherwise not, okay? Partition is mainly from building perspective we use. But here what I'm trying to do is I'm going to upload the file. Okay? I'm going to upload the CSV file. Okay? And then it is a CSV, it will automatically detect. Products is the table name. And I'm going to tell auto detect. Okay, auto detect. And the first row is header for me. Okay, so I'm going to specify. Okay, the 1 second. Yeah, I'm going to specify header rows to skip to be 1. And then number of errors allowed, obviously keep it 0 because you want all the data to be either imported or don't import anything if even one record fails. Okay, and delimiter obviously is comma. Okay, and you can add whatever you want. You want to put custom, you can add it. Okay, but for now I'm using comma. Okay, and then we are going to try it. Okay, so let's see what happens. So we have given the uploaded the CSV file. Okay, and asked it to auto detect the schema. So my guess is this will be string, this will be string, and these two will be numeric. Okay, and let's see how BigQuery does it. Okay. Make sure all the fields are there to continue. Okay, what fields are missing? Let's see. Products, customer, or data set is purchase. Okay, maybe I'll try again if this is not okay. Fine. I'll 1 minute. I'll create one more time and then your table. I think I changed it, but it didn't have it. So this UI also has some bugs. Okay, this is fairly a new UI compared to old one. Okay, so please don't assume that this is without bugs, but easily only minor. So products, native table, auto detect, no partitioning, advanced options, comma delimiter, header rows to skip this one, and create table. And it is creating. Okay, and it created the table. Go to table, we are here. The first thing we want to make sure is it imported all the rows. The number of rows here is 14. The number of rows here is 14. Okay, And then the number of columns here is 4, and the number of columns here are 4. Okay, and then it took first two as string and the last two as integer, as I mentioned. Okay, and since we did not have decimal, it took it as integer. But if we have decimal, it will have float. So now it is imported. You can see the data in preview. Don't write select stop start. Okay, so select. Okay, it is actually limit. So if you put select limit, and then even if you put 1, it is going to query all the records, all the columns, all the tables. Okay, this is a very expensive statement to run. So select start from limit 1. Okay, it is 107 KB, and if you go to the products, the size itself will be 107 KB. Okay, so this is the worst statement you can write in BigQuery. Select star from the table name and limit. It is of no use. It is going to query the entire table. Okay, so instead use the preview feature. Go to preview and then you see what you want. Okay, and then come back and select only the columns and the rows. Okay, so now we have imported the product successfully, right? Now you can write any query, select query, anything on top of it, and then you will be able to work on it. Okay, so this is how we import manually. Okay, and the other way is linking. Okay, I'm going to show you where Google Sheet itself can be done. Okay, so I'm going to now link it so that way we can see the performance difference, all those things. Okay, so create table. This is going to be a drive. Okay, Google Drive. Drive means actually Google Drive. Okay, I don't know why they said. And I pasted the URL of this. Okay, URL of the sheet, and then select type to be Google Sheet. Okay, so select drive, paste the URL, Google Sheet, sheet range. It is the name of this worksheet, products. And once you are here, so now you can say products link. Okay, this is the next table. And here also you can do auto detect. Okay, and then I'm going to say one row. Okay, and since it's external table, partitioning and others are not allowed. And now I'm going to create. So this is an external table. That was native. This is external. Okay, so BigQuery is now becoming a query engine where it wants to support a lot of external tables going forward. That's where it is. Okay, but we are going to see a difference. Okay, so here the biggest advantage is, okay, as we demoed last week, right? If you developed a low-code app using AppSheet, you get real-time data stored in this AppSheet, and you also get the real-time data in the BigQuery. Okay, so now it won't show the count. Okay, so let's run a query. Okay, to get the count and see whether it is reflecting real time. So select count of 1, it will now have 14. Okay, we have 14 rows. Okay, now I'm going to add one more. Okay, one. So now I saved this sheet. Now I'm going to run it. It will show 15. Okay, but if I go to products table, it will still show 14 because we have to manually load it, or a ETL job has to load it. Okay, so so then why don't you link all the sheet instead? Okay, and why go through all the troubles, right? Why don't you link all the data from Google Sheet into Google BigQuery, and then you do it? Okay, so let's play a game here. Okay, so I'm going to run a query for both these tables, same query, and then you will understand why we don't do that. Select star from purchase order, got products. Okay, and again you have to qualify this within the ticks, and this project name is optional. If you have selected in the top, okay, you don't need to do it. Okay, just do this, select start from this. Okay, and where I'm going to take the price range now. Okay, I'm going to run a query off of the price range, purchasing price. Okay, between 30,000 to 60,000. Okay, where buying price, right? Purchase price. Uh, purchase underscore price between 30,000 and 60,000. Okay. So this is for the products table. Now I'm going to run the same query against product linked table. Okay, so now we are going to confirm the performances. Okay. So let's go ahead and run both of them, and we will compare both the jobs and see what happens. So we have this, then this is the original table. Yeah, okay. So now let's go to job information and compare some statistics. Okay, so duration 0 seconds. Okay, bytes build 10 MB. Okay, all those things. Okay, and now let's come back here. Job information duration 3 seconds. Okay, bytes process 2.61 KB, 10 MB. So I hope you can now see the difference. Even though we are built the same, but you can see the bytes processed in BigQuery structure is very almost half, right? This is like 2.61. This is only 1.07. Okay. The reason is BigQuery optimized the storage of the data also very well. That is why it is very small data. And the duration is obviously 0. And this one is obviously 3 seconds. Just for 15 records. Right? So that's where the thing is. Okay. So you cannot link. Performance is the problem. Then, is the criteria that you have to beat. Then obviously linking is not allowed. Okay. We do have linking, but what we use it for is we copy the records from the linked table to the BigQuery table every day. Okay. We also do that one. Okay. So that way, after that, everything runs off of the native BigQuery table. So this is the starting point for BigQuery. Okay. And then you can, as usual, there won't be any foreign keys or anything because I told it's reporting, right? No index, no relationships, nothing. Okay. So you just upload all your data and no relationships can be there. No data integrity can be enforced. Okay. Built in by BigQuery. You have to enforce it in your processes. Okay. So those are things that you have to watch out for. Okay. And this is how, BigQuery gets in. But let me tell you, BigQuery is, you see, every company, okay, needs a data warehouse. Why do we need a data warehouse? First question, right? So that is it's a classic explanation. Okay, single source of truth. Okay, people want to know. Okay, what happened from one place, not from 3 or 4 places of data within the company. Okay, that is why we have it. Okay, single source of truth is what we have, and what we do in BigQuery is we build the unified data warehouse. Okay, that is the project actually. Whatever BigQuery project we work on, the mission is actually to build a unified data warehouse that acts as a single source of truth. Okay, so any data that is in Excel or anything, it will be put it into BigQuery, and thereby, if anybody needs any data, they have to come to BigQuery, and they have to believe what's in the BigQuery to be right. If something is wrong in BigQuery, then the whole company is using it wrong. Okay, so if you build centralized unified data warehouse, it solves a lot of problems for the company. Okay, and again, you have to understand information is perishable. Okay, you have to deliver some information timely to the users, right? If stock market, right? Imagine if stock market does not have real-time notification of prices going down, right? That's it. That information you pass on an hour later, and the guy sees, and his share price already went 20% down, right? So for these things, we have to start building unified data warehouse using Google BigQuery. Okay. So I'll stop with this, okay? And let's take questions. And then again, we will be conducting future sessions also. But as you know, that our Meetup group, right, is actually this is the October and November is an exploratory meeting for Google Cloud, where we cover a lot of things about Google Cloud. Okay, and you might have seen the events are lined up all the way till November last week, right? So the last week's event was low code solution app sheets from Google Cloud using this, and we also showed how to link. Today we are into BigQuery. And the next week, it's actually ETL tool for BigQuery. That is also where you can get the data into BigQuery without writing any single line of code. There is a ETL tool in Google Cloud itself. We can use that. And then Google itself provides Data Studio, and we will also show a demo in addition on how to develop beautiful reports off of the BigQuery data. And then this is mainly for developers. We are going to show App Engine demo, Cloud SQL, and Cloud Storage. Okay, so this is for the developers, and this is for the data people. Okay. So that's the lineup we have. And now feel free to ask your questions. Yeah. And if you want, I just want to show my book as well, okay, which I wrote it's almost going to be 5 years, okay. Um, so learning Google BigQuery. So this is the book I have written when I was in US in 2017. Okay. So that is still relevant for most of the things. Okay, you can try it out. Okay, and then maybe an updated version might come up. But if you are machine learning person, obviously you can go with Lakshmanan's one. He works for Google itself. Okay, and that book is also very extensive. Okay, so this one. Okay, so this is by Lakshmanan. Okay, he works for Google, PhD guy. Okay, and it covers machine learning in that it comes with BigQuery as well. So this is also a fantastic book and more recent one. Okay. 2019. Okay. It's going to be 3 years now. Okay. So and again, writing a book for a technology is always challenging because by the time it is by the time you release the book, most of the features have changed. Okay, so that is the challenge. Okay, so this is how we work with BigQuery. Any questions? At least one or two, so that I feel that somebody got something. Okay, fine. So maybe I'm expecting some questions in the next meetup then after you watch this recording. Okay, and thank you for your time. Okay, and we have been using BigQuery for the last 7 years. Okay, and we have executed multiple projects. So if you need any help, you can always reach out to us. And again, I can guarantee something compared to Amazon, Azure, these two services, all my customers who are in BigQuery are much happier and are paying less money. So with that, I will conclude today's session. Thank you.
Thank you.